Hello and welcome. This is Class 10 Daily Math video and today is December 2nd, 2020. We will find out in this video how do we solve an exam question on finding HCF using prime factorization. So let's take a look at the specific question that we are trying to find out. How do we go ahead and solve? So the question will look something like this. If the HCF of two numbers and two numbers are given to us, they are 156 in this example and 240. So if the HCF of these two numbers is written in the form of an expression, here we have been given an expression. So if the HCF of the two numbers is this, then find the value of this expression. So these questions typically will carry 3 marks and they are very likely to come in your final exams. In the last video yesterday, we saw how do we solve these questions using Euclid's division lemma. Today we will use prime factorization method. So let's go ahead and find out how do we solve these problems. So first we have to find out the HCF of these two numbers. So how do we do that using prime factorization? We have to find out the prime factors for both of these numbers. So let's write the numbers together. So we have 156 and we have 240. So these are two numbers and let's try and find out what are common factors for both these numbers together. Now obviously they both are even numbers, so we can actually multiply them by 2 if we do that. So this will be 2 7s are 14 and then 1 and 6 16, so it will be 8. 2 8s are 16 and here we will get similarly 1 2 0. Now these numbers are still even numbers, so we can again divide both of them by 2. So here we will get 2 3s are 6 and 9. 2 9s are 18 and here we will get 60. Now we have an odd number and an even number, but we see that we can actually, there is a common factor for both the numbers, which is 3, because 3 13s are 39 and 3 20s are 60. Now at this point we cannot find any more common factors because we have encountered a prime number here. 13 is a prime number and 20 is not a multiple of 13. So at this point our process stops and then we multiply all these factors to find out the HCF. So the HCF now will be equal to, let's write all of these numbers. So it will be 2 times 2, which is 2 times 2 times 3. Or it will be simply 4 times 3 or 12. So the HCF of these two numbers is 12. Now we could have saved some time if we would have directly first determined that 4 is a common factor, because what is the divisibility rule for 4? If the last two digits are divisible by 4, then the entire digit is divisible by 4. So 56 and 40, they are both divisible by 4. But let's continue on with the rest of the question. So now we know that the HCF of these two numbers is written in this form and the HCF itself is 12. Let's give ourselves a little bit more space here. Let's clear this out. So what we have is we have 5n minus 13. This must be equal to 12 because that is the HCF. Now we are going to transpose 13 on the other side. So we will be having 5n equals 12 plus 13, which will be equal to 25, and then we divide both sides by 5. We are going to get n is equal to, so this will cancel out, and this will be 5 5s are 25, so n is equal to 5. Now the question is not what is the value of the n. Instead the question is find the value of this expression. Now that we know what the value of n is, we can easily find out. So 2n plus 3 will be 2 times 5 plus 3, or simply 10 plus 3 or 13. So our final answer is 13. So this is how we solve such problems, and I'm going to provide the link for the last video yesterday where we solved this question using Euclid's division lemma. I'll provide that link in the description box below.